This is how a transcritical CO2 system works. So what happens? We go from point 1 to point 2, which is your compressor. This is your vapor section. We're taking low pressure, low temperature CO2 vapor, and we are compressing it to a high pressure, high temperature vapor. When we're above the critical point, what is the critical point? Is when you're above the critical temperature and you're above the critical pressure of CO2. What is that? Those points? 87.8 degrees Fahrenheit, 31.1 degrees Celsius for the temperature, and the pressure is 1055 psig or 72.8 bar. When we're above those 2 points, we are in supercritical or transcritical zone. Now, what does that really mean? This means there's no pressure temperature relationship and there is no vapor or liquid. This is a fluid now. It doesn't matter the compressor. It could be a Copeland, it could be a Bitzer, it could be a Bach, it could be a Dorin, it could be a Frashko, it could be a Vilter. The list goes on. But what that compressor is doing is taking that low pressure, low temperature vapor and compressing it into a high pressure, high temperature vapor. Then we hit something called the gas cooler. When we're above the critical point, it's a gas cooler. And what's happening inside this gas cooler? As the air goes through and we're in supercritical or transcritical mode, that CO2 turns into a fluid. It's not a vapor and it's not a liquid. And it doesn't matter the gas cooler. It could be BAC, it could be Gutner, it could be Ref Plus, it could be Calvion, it could be Thermofin. The list goes on, but they're doing the same thing. We are dropping the temperature of the fluid. This is a sensible heat change, dropping it. No pressure drop, temperature drop. Okay. When we leave that gas cooler and we're in transcritical mode, we go from that point 2 to point 3, which is the high pressure valve. We are actually a fluid coming down to this high pressure valve. Once again, doesn't matter the manufacturer. It could be Danfoss, it could be Sporlan, it could be Carell, it could be Copeland. Once again, the list goes on these components. But what is it doing? It's acting as a restriction. It's acting as a metering device. It is a regulator. So all it's doing, it's taking that high pressure, high temperature fluid and reducing the pressure down back into the dome of the enthalpy diagram. Now it's two-phase. Now we're back into the saturated condition. It is flashing through there. So now we got a percentage of vapor and a percentage of liquid going into the receiver or the vessel. Now what happens inside this vessel, this flash tank, this receiver? Well, it separates all that dense liquid, CO2 liquid drops to the bottom and all the vapor stays to the top. This is where you see the valve on the top. The valve on the top is the bypass valve. It is the flash gas bypass valve. It is the vessel bypass valve or the gas bypass valve. There's many different names for it, but what is it doing? It's actually bypassing any of the flash gas that is disturbing the quality of that CO2 liquid. So what it'll do, it'll open up and it'll close and bypass gas into that medium temp compressor to make sure we have a good constant quality of pressure and temperature liquid going out to all the expansion valves in the system. So what's the next step? We're going from that receiver to our medium temp evaporators. But first, we got to hit that expansion valve. It could be a stepper valve. It could be a pulse width modulation valve. Once again, the manufacturer doesn't matter. There's so many of them out there. Danfoss, Carell, Sporlan, Emerson, and the list goes on. There's so many manufacturers, but what's it doing? It's doing the exact same thing. It's expanding that CO2. So it's taking that medium pressure, lower temperature refrigerant and expanding it. So now it's flashing as it hits the distributor in the evaporator, and that evaporator is pulling the heat out of the product. As the air flies over the coil, it's boiling, sucking in that heat to take it back to that gas cooler. And how does it do it? It goes down the suction line back to the medium temp compressors. Then what else is happening in that liquid line? It's also taking liquid to the low temperature expansion valves. What we just need to understand that it's dropping the pressure even further, it's dropping the temperature even more to pull more heat out of that product. So now we're dropping that temperature down so we can absorb more heat out of the product to freeze it and then back down through the low temp suction line to your booster compressors. These are your low temp compressors or subcritical compressors. We know what it's going to do. It's taking that low temperature, low pressure vapor and boosting it up to a higher pressure, higher temperature vapor. And that discharge from those subcritical compressors, those low temp compressors, go back to the medium temp Compressors, go back to those transcritical compressors. This is how a CO2 system works. If this is something that you work on, I'd love to hear stories in the comments below on how long you've been working on them. What is your favorite part about working on CO2? And if you want to learn more about CO2 transcritical refrigeration, head to the Refrigeration Mentor YouTube page. We got Mastering CO2 with experts from all around the world, hundreds and hundreds of minutes of videos of training and educating from the top experts in CO2 refrigeration from around the world, as well as CO2 experts. Check out that playlist. There's tons of training videos on oil management, on wiring CO2 system, on different technologies coming out. We want to help you get to the next level in your career. And if you want to get to the next level, you can dive into a Refrigeration Mentor training program. We do tons of different CO2 training programs. If your company needs a training program designed and developed for CO2, this is what Refrigeration Mentor do. Head to the refrigerationmentor.com website and check out more there. We'd love to see you in some of these programs. Reach out to me, DM me, because I'm going to get you and your team to the next level in CO2 refrigeration. My name is Trevor Matthews. Let's get a conversation going.